Hi, I'm Brett from hnrstudio.com. I'm an artist living and working in South Florida. This video is part of a series meant to share some of the details about my practice. I want to show people how to take a lump of clay like this and turn it into a piece of plaster. Using this, make something like this. A hard piece of plaster that I can change and modify and work with and eventually turn into a finished piece of artwork. My method of choice is to make a plaster waste mold, and that's what we'll be talking about in this video. The following video, after this one, we will cover the casting of the sculpture and then removing it from the mold. So what is a plaster waste mold and why would we make one? The figurative sculpture I typically make falls into the category of indirect sculpture, meaning I'm not carving directly into my final material. Like I'm not carving something directly out of wood or stone, nor do I build directly by welding or gluing parts together. At least for the figurative elements in my work, I use clay to make a preliminary version of the sculpture that then needs to somehow get translated into a more permanent material. I usually tell people that working with clay only accounts for about 25% of the time that I spend working on a sculpture. That means mold making, casting, and finishing account for the majority of what I do. This piece is essentially a big solid mass of wet, water-based clay, similar to what a ceramicist might use. These images of my work are all pieces that are cast in concrete, but they all began the very same way with clay, just like this, and were then molded and cast in plaster before finally being molded a second time and then cast in concrete. I go through that complicated process because clay, despite being a wonderfully freeing material to work with, has a major trade-off. It must either be fired in a kiln or molded and cast if you want it to last for any period of time, whether you use water-based clay as I do or an oil-based clay. The clay sculpture typically does not have the longevity one desires until it goes through some sort of transformative process. If I were to simply let this clay dry, it would shrink and crack around the wood and metal armature that hold it upright. An oil-based clay would eventually crack from hot weather, even though it's not going to dry. The clay is just not going to be able to hold together with all the expansion and contraction over years. There would also be a magnet for dust and, would be subject to all kinds of, pokes and bumps, kind of like this wet water-based clay right now. So, you don't want your sculpture having an ugly thumbprint in the forehead. And, so we need to turn it into some sort of a hard material that's going to last for years to come. So let me get this cleaned up and then we'll start talking a little bit more about how to make a waste mold over this piece of clay. Just going to wipe up the final little bit of texture here, make sure the form looks good. And yeah, that only took about 45 seconds. So a pretty easy process to fix that big ugly thumbprint. And that's a great illustration of just how wonderfully freeing clay can be. You can make big changes, you can screw things up and fix it very quickly. But mold making is a complicated process. So is it worth the trade-off? And I think that it is. I go through the complicated process because clay, despite being a wonderfully freeing material to work with, has another major trade-off. Certain things that you just can't do very easily when clay is wet. If I were to let that clay dry and get harder, it would be easier to go back and refine the surface and really smooth out those round forms and get rid of the little bumps and undulations. I'm interested in this sort of idealized form. I'm not interested in perfectly smooth surfaces. Sometimes that happens in my sculptures, but normally what I'm just trying to do is I'm trying to refine the surface so that there aren't these weird undulations. I want really clear, distinct convex forms appearing in my work. And clay always just has these little wavy forms and things, these little bumps, little divots, and it's really hard to get rid of. And that's why I use plaster as such a big part of my process. Moving on to materials. What do we need to do the job? Pure plaster of Paris is what I like to use, or the most pure plaster of Paris product that I can find. Plaster is typically used interchangeably with the more technical name gypsum. In the US, I use a product called Number One Pottery Plaster by the company US Gypsum, or USG, but this is not the only product that will work. Different parts of the world will have different products on hand, but with some research, it shouldn't be hard to find something that works. This product is used by ceramicists to make piece molds for slip casting, and my understanding is that it's a very pure gypsum product that does not include any additives to create a harder skin or surface layers, as many of the gypsum products that are designed for making architectural castings do. The plaster of Paris sold at the big box home improvement stores may work, but the quality of the product is much lower. I have seen the stores storing the product directly on the concrete floor, and that certainly does not help. Concrete can transfer moisture from the ground below into the plaster and spoil the product. I have heard of someone losing their sculpture by using a bad bag plaster from one of the big box stores, so be careful and test your plaster if you're going to go this route. USG also makes a product called molding plaster that is similar, but I think it's a little softer, perhaps less pure than pottery plaster. Maybe a little bit more like a good bag of the plaster of Paris that you might get from the big box stores. So the next three materials that are all extremely important to this process probably are best to get at a building supplier or your local big box store. So unlike the plaster, these things are easiest to find there, and the quality is totally fine. You don't have to go all over town searching for some sort of specialty product. So we're talking about wide weave burlap fabric. At one point, I knew the sort of technical rating for this specific size, and it's kind of a confusing thing. It seems like maybe there isn't really a great standard out there, but I'm looking for holes that are maybe in the 2 to 3 millimeter square range. That's about an eighth of an inch, somewhere in that ballpark. As long as it's close to that, then it's going to work. What you don't want is these strands in the fabric to be so close together that you can't easily see through it. You want to be able to see through the fabric reasonably well, because we want the plaster to be able to pass back and forth between the two sides. So do not buy anything that is sort of a tighter weave burlap. That's not going to work for you. So next on the list is aluminum flashing. Aluminum flashing is just some thin aluminum that you can find in the roofing section of a building supply store. And it's just a very thin piece of aluminum. We cut it into strips, usually smaller than this. And this is going to be stuck into the clay, and it's going to form the parting line to separate the various parts of our mold. I'll talk about that more later. Some people do use aluminum cans. They will get some shears and cut aluminum cans up into strips. I think that that's a little dangerous. It's easy to cut yourself, and it's a whole lot of work to get a shim that's just slightly thinner, and it really doesn't make that much of a difference. For me, as long as I'm working with something on the larger side, I certainly prefer this slightly stiffer material. Maybe if I were making very small little delicate molds, I'm I might prefer a thinner material, but at that point, I would rather just go out and purchase a thinner aluminum and, deal with, special ordering it from an industrial supplier like McMaster-Carr. I have ordered shim material from them, and that has been, fantastic. There's a product called Shim in a Can, and it has this really cool little can that it comes in. Moving on, the next product that I want to talk about is what an electrician might know of as EMT. It is a conduit. It is the steel pipe that you see all over the insides of industrial buildings, and this is a 3/4 inch pipe, meaning it's 3/4 on the inner diameter, and I usually use 3/4 or 1/2 inch. Either one will do. For bigger molds, I tend to go with the bigger stuff. Smaller molds, the smaller stuff might be a little flexible for a really big mold. So it's always good to have some of both around. I really don't use anything bigger than 3/4 most of the time, unless it's scrap that I find in a dumpster for free. This stuff is nice to have new, but it's one of those materials that you can often find, cheap, and you can pull it out of dumpsters. You can use anything really, but this is the easiest thing to buy if you don't have access to some sort of recycling heap or something like that. Now we've discussed the main 4 materials that we're going to use to make a mold. I'm sure you're excited to start mixing some plaster, but before we do that, we have to talk about how we're going to design the mold. So we have left my workshop. We are out here in the H&R Studio classroom, and I want to talk to you a little bit about the design of molds. So the concept that is most important to this video, the thing that I want to get across to you more than anything else, is this idea of draft. Draft referring to, how easily the pieces of the mold break away from the object that we're casting. So, we're not talking about drafting as in, pencils and paper, but we're talking about draft as in, the design of boats, and how a boat sits in the water and how low that keel is in the water. It's the same concept. We want to talk about the surface area and the friction in which is created when we're pulling pieces of the mold apart. So I have come up with some paper templates, and we're going to talk about those right here. Let's imagine that this oval of paper is our clay sculpture. Let's imagine that this is a cross-section of our clay sculpture of which we want to make a mold. So what is a mold? How does this work? We need to create some sort of a shell that surrounds this piece of clay and makes an exact copy of the negative space that surrounds this piece of clay. So we're going to use plaster because we're going to mix plaster to be a liquid that hardens in a matter of minutes. So we're going to mix up this soft slurry of plaster, and we're going to make several coats that surround this like an eggshell. And then in the end, it'll be like having an eggshell that you can pull apart into 2 separate pieces, and you can fill the inside of each shell with more plaster and stick them together. Then you break apart the shell, and you're left with an exact copy of that egg that was on the inside. Let's assume it's a hard-boiled egg. I left that part out. It would be hard to make a mold out of an egg that was not hard-boiled. So how do we determine where we're going to split that eggshell apart? So if we put our sculpture over here, and we take our eyeballs, and we put our eyeballs over here, we want to break this mold apart wherever there's a horizon. So If our eyeballs are over here and we're looking in this direction, where do we see the form turn around? Where do we see a horizon where that form disappears, much like you're at the beach and you're looking out at the ocean, and there's a spot where you just don't see anymore. So from here, this is the same exact thing that's happening. Your eyeball is looking, 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 and it can see this surface, it can see this surface, and then all of a sudden there's a point where it disappears. So we're thinking about this as being the horizon. So when I'm making a mold, I like to establish some different points where I'm going to look at this and I'm going to find those horizon marks. So I might go into my clay and I might draw right on the surface of my finished sculpture with a tool and mark out where those horizons are. So I would walk back to this spot and I would try to pick out what that spot is, and I'd walk over with a tool and I'd make a little line right on the sculpture with a tool, and then walk back to that same spot and make sure that it looks like that line really is on that horizon point. We're going to draw another horizon point on the other side. And in theory, when we turn this around and we look at the sculpture from the other side, we hopefully can imagine seeing that horizon in the exact same spot. So in theory, I'll turn this around to the first side again. If we were to cover this entire thing with a shell of plaster that was strategically divided into a seam here and a seam here to create those two parts, we would get a mold that functioned very well. So let's pretend this is our shell of plaster on one side. So I didn't quite hit that spot, but that's okay. And we'll pull this wall over onto the other side. So as we pull these hardened shell walls away from our soft clay sculpture, we should be able to slide these right away without having any issues of undercut. Undercut is when these walls wrap too far around to one side. So imagine, see, we almost have a little bit of undercut here on this end, where we're going to slowly pull this away, and you can see that we do that unless we move this out in a perfect line, we start to hang up this little edge. And so, if we're making a mold of something soft, like a water-based clay, hopefully our clay is soft enough that this clay will sort of tear away before we get a break in our mold. So, as you can see, when you're just dealing with a two-part mold, this can be a little tricky. Even such a simple shape, it's very easy to end up with a little spot where you start to hang up a little bit. And, again, that's okay if you're dealing with a very soft material like a water-based clay. That starts to become a little bit of a problem when you're dealing with an oil-based clay, because the oil-based clay is going to be a lot stiffer. And so you really have to make sure that you are not having any issues like that. So another way that I like to split up a shape like that, this oval happens to be, or this egg shape happens to be very close to the shape of our skull. So what I might do is I might divide this mold up into 3 sections. And so this would be an example of a mold that is very well drafted. So there's no chance that anywhere here we're going to have an issue pulling away these walls. All these walls are going to pull away. Get these out of the way. All these walls are going to pull away very, very nicely from one another. The issue some people have with a mold like this is that assuming this were a head, assuming this were a skull in this egg shape, what's happening over here? This is going to be our face, right? This is going to be where the nose is, right down the center. So, do you really want to have a seam running right down the center of your face where you have all that detail? And I am of the belief that in many cases there's nothing wrong with that. I think that it's much easier to chase. Chasing means to clean up the seams after a casting has come out of the mold. I believe that chasing a line running right down the center of your face is preferable to what many people do. And many people will say, okay, well, I want to preserve all the detail on the face. So they're going to take their eyeballs and they're going to look at the front of that piece of clay that's in the shape of a head, and they're going to say, okay, the wide points are back here. So this is where I'm going to divide my molds. And that lets me preserve any detail that I have going on in the face. So I'll just build my mold flanges here and here, and in theory that mold should slide right off because we have that nice tapering shape of an egg. So let's see what happens. We're going to build a mold wall on one side, and then we're going to build another piece of the mold onto the back side. So yeah, we're roughly where I put those arrows. So what happens when we go to pull this mold apart? So I'm going to pull and pull and pull, and we're starting to hang up just a little bit right here. I wasn't totally perfect with, where I put my parting line. And, you have things like ears on the side of your head, and those are going to further complicate everything. So while this will often work, I would much rather deal with a purposeful mold seam running right through the nose and the mouth, where I can place that mold seam directly where I want it and know that it's going to be a small area to clean up, than risk having this really deep mold and potentially cracking the mold. And then if you have some sort of series of cracks across the face, that might be more work to clean up. Not saying that it can't be done. I have made much bigger mistakes making molds, and I've had very, 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 bad things happen where I've had to, essentially, rebuild entire sections of mold shell. But that's a whole lot more work that we would rather not do. We want to spend our time making things in clay, or maybe doing other things than trying to repair molds. So I would say that it's a much better use of your time having a seam right down the center of a face than risk having some sort of breakage and then having a lot more repairs to do. So a really great illustration of that concept happens when you want to make a mold of something that is square. Let's assume that maybe you have a base on a bust, and that base is roughly square shaped. Let's say that you've made this bust out of clay, and you have a clay sort of square-ish bottom to the thing. And let's take our eyeballs and let's move them around to different places. And this is square, right? So in theory we have the same width all along this side. So where do we put our seams? Do we divide this up so that it's right in the middle? In theory, if this were a perfect square, we could build a wall on one side, and we could build a wall on the other. And then we should just be able to slide these apart. But we're going to have a whole lot of friction as we drag these sides across that surface. So even if this is a perfectly machined square, this is going to be virtually impossible to pull this apart. If you have some very soft clay and you're very patient and careful, you might be able to get away with that, and that might work out for you, depending what kind of other problems you might have in the upper part of the sculpture. This might be something that you might try to approach. I would suggest, however, that rather than thinking about looking at this from a front or a side, we're making sculpture. We have to think about things in the round. Just take a step over and just think about what this looks like from. Let me swing my arrows around. Think about what this looks like if you're looking at one of the corners. So I'm going to get this out of the way. We'll bring in another square here. Think about dividing up the square from these corners, and think about how easy that might be to pull away a side that was divided from the corner. That would also give you the benefit of doing your chasing, cleaning up your mold seams right on top of that nice corner. So if you make your mold and you clean up your mold afterwards, you're probably going to end up losing a little bit of material around this corner. And then when you make your casting and you pull the mold away, you're going to have a little bit of extra material that's built up on this edge, and it's going to be very easy to go back in and clean up that edge. So I would definitely recommend doing everything you can to give yourself a situation more like this than like this. This is going to give you a lot of headaches down the road, and having the best drafted mold is going to make your life so much easier. So what happens if we have some organic shapes that are more complex than just an egg? I'm going to slide these things out of the way, and we'll keep these arrows out and handy. What happens if you have a shape like this? This shape is, really, is really kind of weird. You have, these weird bumps and, these little deep, notches. So you got to take your eyeballs and you have to turn the sculpture around. You have to walk your eyeballs around the outside and think about, where you're seeing different horizons. So if we're looking from this direction, we might be seeing a horizon right here. And then maybe we're seeing another horizon over here. And so in theory, we should be able to make a piece of the mold that will pull away nicely, stretching from here all the way around to here. One big piece of shell that will then slide away from the sculpture with ease. And maybe we turn our eyeballs around to this side and we think about where the next horizon might be. So if we have something like this, we're definitely on the near side of the horizon there, and we're on the near side of the horizon here. So I might make a piece that pulls away in this direction. So I've already prepared some walls for this piece. So let's see if I can get this in the proper orientation so I can get these walls in. So the solution that I came up with involves a series of 4 pieces. Oops. So I'll explain to you why I divided the mold up the way I did. So if we pull our eyeballs around to this side and we think about looking at the sculpture this way, this is a nice big wide flat expanse. This gives us one large piece. This is the side that has the least amount of detail of this sort of complicated shape. So I'm going to take the side that has the least amount of detail, the least amount of complication, and I'm going to keep that as one large piece. That way, this will form as sort of our base. So if this was a very large mold, if this were something that were like a life-size human figure, you would be able to support this side very well with, say some steel conduit, like we talked about in a previous segment. So that steel electrical conduit would get piled up on this side to give us a whole lot of structure and keep this side really strong, while we have a series of smaller pieces that, because they're smaller, they have a much better chance of being able to pull away nice and easily without breaking. So we won't have them breaking and creating any sort of distortions. But even if they do, even if we are able to get away this piece and this piece and this piece without breaking, but for some reason we get a crack in this piece, once we bolt together, so after we've removed the mold from the clay sculpture and we're bolting this empty mold back together again, we'll be able to use the structure created by these other pieces. We can bolt this together here, and we'll be able to add some more plaster and burlap to the outside, which will give us a reinforcement. And if we have this all locked together, then we know that we're repairing this and we're sort of reforming it into the proper shape. So those are the basics of how to properly draft anything that you want to make a mold out of. We just have to make sure that anytime any of these mold shell pieces need to slide away from the surface of the sculpture, that they can slide away without getting caught up on the flange from the piece next to it. They're not going to get caught up on anything on the surface. We have some flexibility with water-based clay, with the waste mold that we're making in this video, because the water-based clay is so soft that if there was a reason that we needed to permanently join these 2 pieces of mold, and we had to think of this group of 2 pieces as one piece, and we had to pull it away in this direction, you can see that this would act as an undercut. But this little lump of clay, if it's a nice soft clay underneath, if we've done a good job keeping our clay wet, and then we've maybe let the mold soak in a tub of water overnight, this clay is going to be very soft, and we're going to be able to pull that section of mold away, and this clay will just break and tear, and hopefully it's the clay that tears away and our plaster shell will be left intact. So now that we've discussed these sorts of principles about how we're going to divide the mold, let's head back to the shop and we'll talk about how we're actually going to split up the sculpture that I've been working on. All right, so we're back in the shop, and now we are ready to talk about how we're going to divide the different pieces of this mold. So where are we going to create our parting lines? we are going to spin this around several times and take a look at where we might see some undercuts, where where the ideal places might be to divide this form. So I've got some ideas. I'm going to spin this around nice and slow. Let you think about the sort of things that might trip us up. So right off the bat, we can see that one issue that we're going to have is this hand that sticks out on the front. The thing that I'm going to bank on when I think about dividing this sculpture up is that I know that I placed this hand on kind of loosely. There's sort of a staple of armature wire that holds this hand in place, and I know that I'm going to be able to soak this mold in a big bin of water once I've finished the mold, and that's going to soften up all the clay and make it really easy to pull things apart. So I know that I can get away with some undercuts, and one of those things that I know that I'm going to be able to get away with is completely enclosing this hand and then being able to dig the soft clay out of the inside of the mold. I'm really confident that I would be able to pull the mold away from the front of this sculpture and have the hand stick in the mold, go away with the mold, and then I would be able to pull that clay out of the mold afterwards. So I'm not going to worry about that hand. I also want to think about how far underneath I want my mold to go. I want to preserve this texture of the clay. I want to preserve some of this, some of this haphazard sort of texture that's happening below the sculpture. And I'm not entirely sure exactly how the base that sits below the sculpture is going to be situated. I have an idea about what I want to do, but I'm confident that if I have my mold wrap around the underside of the sculpture by 2 to 3 inches, that I'll be able to figure something out with plywood. If I need to build out a little bit more of this rough texture, I think I can do that with wet plaster. Really, I'm going to continue designing this piece as I go. That's something that I do when I work with plaster. The plaster stage for me is still very much a part of the creative process. Some people like to think of this finished clay as being the end all be all for the sculpture. This is the sculpture in its most pure form. And to me, this is just a stage, and at this stage it's pretty far along. It's a pretty good representation of what the final piece is going to look like, but it's not all there. I have a certain amount of work that I do inside the mold to kind of further refine forms, and this is not a perfect representation of what I want the sculpture to look like right now. So that gives me room to to work with the plaster a little bit and to continue making some aesthetic decisions as I go. So if I am looking at this sculpture, I know that I only want to cast 2 to 3 inches kind of around the underside. So I'm really not going to worry about this piece of wood here that's supporting this shoulder. I think I'm going to make my mold right up to this piece of wood under here that is supporting the majority of the sculpture. And then, every place else, I'm just going to wrap around, 2 or 3 inches. And I think that if I make that turn strong enough and I soften the clay enough by soaking it, I think I'm going to be able to keep this mold to just 3 pieces. I know that this is a small enough piece that I will be able to find a large plastic bin or trash barrel or something to turn this mold, to turn the mold and the piece upside down and soak them in water overnight once I've got the mold finished. That will soften the clay and it'll make it a whole lot easier to separate the pieces of the mold once it's finally finished. I think that what I want to do is I want to start by working off the most simple side, just like I did with some of those paper templates. And I think that this back is the most simple side. So right now, from where the camera is, think about the sorts of horizons that you're seeing as your view comes and it hits this shoulder, and how the form wraps around. Think about what's the maximum point at which we could separate this mold. So we'll start thinking about where that might be. This back area is relatively flat. There's a lot of texture in here, but it's a relatively flat area, and so this will be a pretty simple section of the mold. Since this area is relatively flat, and these curves around where the trapezius are kind of mild, I don't think that I would be too worried about coming too far around. But of course, I think I'll probably play it safe, and I'll keep my parting line just a little bit in front of that horizon that you're seeing from the camera. So I'm going to go ahead and just start marking a few spots here and there. I'm using a wax tool that has a flexible spatula, and these are really fantastic tools. And I got this one in Italy many years ago, and the best ones are the ones that come from Italy. Unfortunately, they are hard to get here in the United States. So if you ever travel to Italy, make sure you seek out an art supply store that carries sculpture tools, because these things are incredible. So I'm going to move around to the other side, and I'm going to think about, where is that horizon when you're looking at this view from the back? I'm going to think about letting that line cheat a little bit around towards the camera to make sure that it's not quite so difficult to get this mold off again. If you decide that you've put a line in the wrong place, it's really easy to just take your finger and lightly dab along the line and smooth it out, and it'll be as if nothing ever happened. So it's really easy to go back and change your mind. Don't be afraid to do that. So if we've started to think about where our parting lines are in the back, let's see, I'm going to add a line up here for the head. So notice I'm not coming all the way out to this horizon on the side of the head. I'm not coming all the way out to the horizon on the other side either. I'm cheating my way a little bit to the inside because I want to stay away from this ear. And what I'm going to be doing in the front is I know that I want to create a seam that comes right down the center of the face, much like I talked about. So this will be a very deliberate parting line right through there. And I'm going to divide this right up over the high point on the back of the hand, across those knuckles. So that's going to give me the ability to pull one piece off in this direction and to pull another piece off in this direction. So we have the placement of the line coming right up the forehead, and we have the lines on the side in the back. So what I'm going to do is just continue those up to a place where they all meet right on top of the head. This is, oops. Actually, see right there, I just changed my mind. I want to stay away from this little spot there where our metal element interfaces with the head. Be a little easier for me to just stand clear of these spots. Make sure that I'm missing those. So I can go back and redraw my lines to make sure that those are out of the way. Connect right there. Notice right in this spot, make sure you note how I am keeping my parting line out of this crease. So any sort of turn that I have, I'm trying to keep my parting line on the high points as much as I can. It's always easier to clean things up in your finished sculpture if you have them up on high points. It's a lot more efficient to keep them on the high points, and it's a lot easier to work over those convex forms and make those lines disappear than it is to try to scoop in there and get into those concave areas. I did create a parting line that goes right through these knuckles here. And I want to mention that I purposefully put that parting line right on those knuckles rather than putting it out on the back of the hand, rather than putting it through the middle of the fingers, because I want to keep that parting line up on top of the high points. Because again, it is so much easier to do your chasing when your repairs have to be done on top of high points. It's a lot easier to add material and grind it back down with sandpaper or a rasp or riffler when you have that parting line sitting on top of the bigger, rounder forms. I could get away with putting it through the back of the hand, but it's going to be a lot easier to rebuild the detail that's happening on these knuckles rather than this sort of complex area on the back of the hand. All right, so I have drawn parting lines all over this entire form. Well, I wouldn't really say all over. We just have 3 parting lines. This will only be a 3-part mold. So now the next thing I'm going to do is I'm going to stand back and I'm going to look at this from all sides and make sure that I can imagine positioning myself directly in the direction that the piece of the mold is going to come off. And I want to make sure that I have an idea that I can see this parting line all the way around, so that I know that that parting line isn't stretching too far around in any one direction. If I see that parting line disappearing on the other side of a horizon line, I know that I have placed it in the wrong place, and it might be impossible to get that piece of the mold off without breaking it. So I'm going to take a little bit of time here, and I'm going to walk around the sculpture a few times. I'm going to turn it around a few times, and I'm going to double check, triple check that all of the sections of the mold can easily come forward away from the sculpture without catching on one another. In a more complex mold, you might have to worry about there's some sort of turning or some sort of twisting element. Sometimes as the figure turns, if there's a twist in the figure, sometimes it makes sense to have a piece sort of twist and follow the figure. and sometimes you can kind of lock yourself in with the other pieces around it. So imagine, you know, so you have to imagine that we're going to have flanges that are sticking up out of these parting lines. Those flanges are hopefully going to be more or less perpendicular to the surface of the form. And those are going to form the walls that help us, separate this piece and clamp it back together again. So imagine that you have those walls standing up nice and straight. You have to imagine that those walls aren't going to, inhibit you from pulling pieces of the mold away from the surface of the sculpture. So one issue that I'm starting to see over here on this side, let's see, if I position this right here, right in, so the mold would have to come away in the direction of the camera. What I have going on here is that this parting line on top of this trapezius kind of swings around towards the camera a little bit. So that could be a little bit of a problem. If, let's see, I might go ahead and simplify this line a little bit. I was keeping it up on top of the high points, but what I might do is push this line over. We let this line follow the high point, which is what I typically do, and we go to pull this, part of the mold away. As this hooks around, that might start to, this vertical flange might start to catch and rub together. So I want to bring that flange around this way so that when this piece comes away, we're not sort of hooking back in towards the center of the section of the mold. So we're just going to rub away this line right here. Just very simply take care of that. And now we've pushed this flange a little bit towards the outside, and that will help us free this section of the mold as it pulls away in this direction. And that just gives us a little bit of a cleaner line coming through here, and it'll be a little bit less to get caught up on as we pull this flange out. That'll all make a little bit more sense once we actually start inserting the aluminum flange material. Alright, so now that we have drawn out all of our parting lines, we are ready to finally begin making this mold. So, where we have these parting lines drawn, we are going to start inserting some of the aluminum shim material that we talked about earlier in the video. Using this aluminum flashing material is not the only way to divide the pieces of your mold. Another way to do it might be to use strips of clay and to form the clay into a wall around the area where you are going to divide the pieces of the mold. For me, that's not the best option, or at least it isn't for this particular sculpture. One reason why that's not the best option for me with this sculpture is that this clay is a little bit sticky. This is the wed clay from Laguna Clay Company, and I believe it might have a little bit of ball clay in it, which tends to be a little stickier. So it's great for sculpting in that it stays wet for a long time, but it's a little on the sticky side. And for mold making, when you stick on a clump of clay to create that wall, and then you peel that wall away, you end up with a whole lot of junk that gets left behind. Some types of clay you're able to stick on a wall of clay, and when you peel it away afterwards to make the second side of the mold, it's really simple and easy. You just peel that clay away and it's like nothing ever happened. With this particular clay, I'm left with all kinds of garbage that then I have to go back and clean up. It doesn't peel away from the plaster very well when the plaster is set up against the clay. So for that reason, I like to stick with this aluminum shim material. So what we're going to be doing is we're going to be taking pieces of this aluminum shim, and you're going to be very careful. This stuff will very easily cut you. I I cut it using either tin snips or sheet metal shears. We've got two options. And you are essentially just going to cut it into strips that are about 1.5 to 1.75 inches in width. And we're going to stick them right into the clay. And we're going to try to keep them perpendicular to the surface of the clay. So this is a little bit of a funny spot here. I'm not really happy with how that went in. Because I have this kind of lump here in the clay, I think what I might do is I might just shift this piece over a little bit. And that'll give me a little bit more room to work. So again, trying to keep it perpendicular. I pick up another piece. I want this wall to kind of follow around the outside. So all right, so there's my first piece. I have left it a little bit long sticking out here because I want to be able to match another wall sort of coming around this way. And I'm going to take my shears and I'm just going to snip that right off. So that we're going to try to match this contour all the way around the sculpture. So now I'm going to grab another piece of aluminum. I'm going to try to make sure that I can match the angle that I have there. So I'm going to snip a little bit of an angle off so that hopefully we can match this angle. And I'll stick that little bit of stick right in there. And I'm going to keep on going and work my way around the entire sculpture. Alright, so as I'm doing this, I am continuously spraying the sculpture. I want to make sure that it stays nice and soft. We don't want it to be drying out and getting hard as we try to stick our shims in. The nice thing about using shims is they are really not affected by a little bit of extra water. One thing I want you to take note of is I'm trying to give myself a little extra room around this ear. So I went a little bit off of the line that I had drawn in the clay, and I'm making sure that when I have a nice thick layer of plaster covering this ear, that I'm not going to be building up that bulging plaster to cover the ear right up against this wall. So if we're building up maybe a 1/2 inch thick layer of plaster over everything, that's probably about as thick as we want to go. We're maybe it's a little thicker along these flanges or along these dividing walls. We want to make sure that we have room to get a bolt or a clamp in here. So imagine this ear getting kind of covered over by a blanket of plaster. You want to make sure that you still have a little bit of room in here so you can get a clamp or be able to pass a bolt through there. Sometimes you can't avoid something like that, but wherever you can, you want to make sure that you're giving yourself plenty of room to add some clamps all along this wall. So you don't want that to interfere with the rest of the sculpture. Again, giving myself plenty of room here so that when we cover over this ear with a nice thick layer of plaster, I'm still going to have room to grab onto this area with a clamp or pass a bolt through. While this time lapse is going on, I just want to explain that I have a studio in South Florida, so that means that whenever there's a thunderstorm rolling by, I get some noise of wind and rain rattling on my overhead door, so excuse that background noise. As I'm going along, I brought this wall down, and this flange wall, this shim wall, is starting to sort of fall over. It's starting to become a little bit less than perpendicular. So the way I fix that is I might have a piece with a little bit of a bend in it, and I might go to hold up this piece at the angle that I want the flange to sit at, and I'll sort of reinforce this bend, and I'll sort of eyeball the difference in the angle between the existing flange and the new flange, and I'll just snip off a little bit of material so that I have this funny angle, and I'll try to make a nice joint so that these pieces line up nicely. And now the wall has a little bit of a kink to it. And that little kink is actually an advantageous thing to have. So what's going to happen is anytime we have a very straight section of parting line in our mold, those two pieces of the plaster mold, when they're coming back together, when they're empty inside, they're going to want to slip and slide against one another. So these little jogs and little dips, these little sort of kinks in the wall, those are naturally going to help register the multiple pieces of the mold back together again. So I don't need to add in a whole lot of keys and things to really make these pieces of the mold pop back together in just a certain way. Oftentimes people will add little sort of half round balls and things that will project out from the wall, and then they'll remove that form and they'll build the other wall on the other side, and you have this beautiful little key that helps those pieces lock together. I don't really think that's necessary, especially not for a waste mold. This is a mold we're going to use one time. And as long as this wall is not perfectly straight, and it has all sorts of little jogs, and it isn't two planes, we don't just have a front and a back. We have a sort of angled, a sort of angle coming out from the form. If you've ever carved a pumpkin, it's much like when you cut open the lid of a pumpkin. You don't cut with the knife straight up and down. You sort of angle in so that as you cut around, you're forming a sort of section of a cone, or it's some form of a wedge, so that when you put that top of the pumpkin back on, it doesn't just fall inside the pumpkin. We're doing the same thing here, where we have this sort of angle shape here, and that's going to keep these pieces sort of locked together, and it's going to keep them in just the right orientation. So I don't need to go through the extra work of adding little keys onto this mold to make sure that everything locks together just right. if this were being made just as a front and a back, and I just had one very straight wall that ran up through the middle and down the other side, then yes, I probably would need to add something to keep those pieces from sliding in space against one another. It would be very hard to get the mold to sit exactly perfect when you put it back together again to make your casting. With this sort of a wall, I am not worried about that whatsoever. Alright, so we now have a flange made with aluminum along every line that we drew in the clay to divide the mold into different parts. So we can now clearly see what the shape of this back piece is going to be, what the shape of this side piece is going to be, and what the shape of this side piece is going to be. So at this point, you really want to take a look, and again, you want to kind of situate yourself so that you have a view that is the exact same angle at which the piece needs to come out. So we want this piece here to come out sort of, away from the other two. So you want to sort of position yourself so that you're sort of right in the center of it, and imagine this piece coming straight out at you. And you want to look for any place where that mold might get hung up. So the only place I'm seeing that might be an issue here is that we have this little corner down here by the thumb. And as the mold comes away, we might get a little bit of a sort of an undercut like we talked about before with clay, except this would be against, it would be the mold wall getting hung up on the wall from the other side. So I think that this is just, it's just kind of borderline, but I think I'll be able to slide this piece out. So I'm going to go ahead and leave that the way it is. But now is the time to change anything like that. If you aren't going to change anything, the next step is to take your snips or your shears and to go around and start cleaning up some of the issues that we have in this profile of the aluminum. One thing I like about this aluminum is that it's very easy to come around and clean up a lot of these areas. I want as smooth of a profile around this aluminum flange as I possibly can. That's going to make it easier when we're building up plaster on either side to drag a tool across this edge and make sure that we have a nice distinct division between the two sections of the mold. If we have if we have odd profiles here, it's going to be harder to keep track of, which side of the mold is which, and it's going to be really easy to get those two sides sort of stuck together. So I like to keep everything nice and smooth and round, and part of how I do that is after I've stuck all these walls in, if there's any spots kind of like this that really poke up, or this weird jagged area here, it's really easy to go through and snip those areas off and create a nice a nice profile. So I've got a snip there. You also might have issues like I'm getting right here around this mouth and nose area, where we get the two pieces sort of separating. They're sort of, you know, they're spreading apart. And what that's going to do is if we were to put plaster on this side and plaster on this side, we would end up with the plaster leaking through between there, and that would connect this part of the mold to this part of the mold over here. And we want to keep those totally separate. We want to seal out all the plaster that's happening on this side from all the plaster that's happening on this side. So what I'm going to do is I've just made a little tiny slit in this piece of sheet metal. So I can just sort of slide these together and make sure that our seams are nice and tight and we don't have plaster flowing back and forth between the two sides of the mold. So it's a little bit of finicky work, just going through and tweaking and adjusting everything. Another thing that I did over here on this side was I had one piece of aluminum that was leaning one way and another piece of aluminum that was leaning the other way, and I had an area where that plaster could join the two sides of the mold together. It was going to join this front piece to the back piece if I left that area open. So I was able to make a little clip, and I just sort of squeezed those two together with a little overlapping clip, and that's going to do just the trick to seal up the two sides of our mold and keep the plaster from flowing back and forth. The third and last little trick I have for smoothing out the profile of the shim line and neatening things up is to use a little bit of packing tape. This should be the last thing you do, because oftentimes the water that you're spraying on your sculpture to keep it wet will make the packing tape peel off. But it is sometimes all you need to just get you onto that next step in the process. All right, I have reconfigured my workspace so that I am ready to start working with plaster. I want to run you through what that means, what I've done, what sort of tools I have here, how I've set up my space so that it's easy and efficient to work with this material. So I have my sculpture here. I've been spraying that with water, keeping that wet. I have a table, which is just a couple sawhorses and a piece of plywood. And this is, this is sort of my workshop folding table that is just, always handy. It can be folded away and, taken back out again really quickly. Today I'm going to be cutting burlap on here, and I'm also going to use it to throw my buckets once I'm done with the mixing. Another thing that I have right on the table is a half-face respirator with a particulate filter on it. We are going to be using some dusty things, and this is one of the steps that we're going to take to protect ourselves from those dusty things. Next is a sharp pair of shears. These are, these were actually my grandmother's, and I've been using these for well over a decade, and they are one of my prized possessions. I keep them sharp. They're a little bit rusty. They are a little bit caked in plaster and concrete, but I do take care of them pretty well, and they are a very important tool in the shop, as you'll see. Next, I have a little mixing table. So I slapped together this little mixing table / dry powder storage cart out of some scrap wood this past year. It has a little laminate shelf on top with some laminate that I pulled out of a dumpster, and I made the base out of some 2x4s and some scrap MDF and some leftover casters from one of my sculpture stands. I have a postal scale on here with some angle iron that supports the readout so that it's easy to read what I'm measuring down here. I'm not using this for mixing plaster. We're going to mix our plaster visually. So we're not going to use the scale at all, but I am going to use this handy little cart. And right behind the cart, I have strategically positioned my air cleaner. So this little air cleaner unit is not necessarily big enough to cover this whole shop, but I keep it right next to where I'm working. And it's really important that you're trying to control any sort of dust that you make as much as you can. You don't want to be breathing any of this plaster or concrete dust as you're making molds and casting. That stuff will get into your lungs, it'll harden there, and it will give you some real health problems. So we have the air cleaner, we have the half-face respirator. Normally a regular N95 mask will do, but I have a beard, so I like to cinch down the respirator a little bit tighter. Ideally I would be clean shaven, but I do feel confident that running this air cleaner and wearing my half-face respirator, that I'm taking the necessary precautions and I should be pretty well protected from any dangers associated with my dusty plaster. I will mention, however, that the microphone is going to be picking up noise from that air cleaner, and you're not going to like listening to me talk through my respirator. So rather than trying to yell through my respirator over the noise of the air handler, I will be voicing over a lot of the video from this point forward. You may have noticed the ridiculously tall stack of peanut butter buckets that I have next to me. And yes, I used to live off of peanut butter and jelly sandwiches. And where I grew up in the Boston area, you could get these 3-pound buckets of peanut butter, and they are the perfect mixing buckets. I use these for everything, and although I'm no longer eating this peanut butter, I still have a collection of buckets that's a good 10 years old, and it serves me well. I like having a lot of buckets so that I don't have to clean buckets in the middle of making a mold. I can just lay all these buckets out to the side and let them dry, and once the plaster is hard and dry, it's a whole lot easier to pop out of the inside of the bucket. Last but not least is a bucket of water. I keep a 5-gallon bucket full of water on top of another 6-gallon bucket, so I have a comfortable working height. And I do all of my preliminary rinsing and washing in this bucket, and that keeps the drain in my sink from getting clogged. Before we start mixing plaster, the last thing we need to do is cut some burlap. So when I'm cutting burlap, I like to cut nice and straight along with the weave of the fabric. That helps keep everything together when you wet it down with plaster, and it keeps the fabric that we're cutting from falling apart into just a big pile of strings. Sometimes it's handy to have a big mess of strings left in your bucket afterwards, but really I like having some rectangles or squares of some sort, and I like a variety of sizes. Having a sort of longer rectangle that I can fold in half into something that's more of a square shape helps me build up the thickness and the strength a little bit more quickly. I'll probably end up using about half of a roll of burlap for this mold. So we do go through a lot of it. So don't be afraid to cut extra, because you can always use it for a future mold. You can use it for the casting. When we go to cast this piece, having more of this burlap on hand pre-cut is not a bad thing. So don't be afraid to cut as much as you can handle. And after I've cut the burlap, I dunk it all in a bucket of water. I let it soak for about half an hour and make sure that the water really gets every sheet wet. Sometimes even after half an hour, there'll be some dry spots in the middle, so you want to open it up and let the water into the middle of the clump. All right, so I've cut my burlap. I've got it soaking in a bucket. So now we're ready to start talking about applying plaster to the surface of the sculpture. So to do that, first we have to start mixing some plaster. We've talked a little bit about my favorite buckets here, the peanut butter buckets, and these buckets have been nicely cleaned. The majority of the plaster is out of the inside. Some people do spray a little bit of a light lubricant on the inside of the bucket to aid in the release of the set plaster once plaster has set inside the bucket. I don't always find that to be necessary. Usually these buckets are soft enough that I can sort of squeeze the bucket and I can get that hardened dry plaster to pop away from the edges. So I'm going to start with a clean bucket. I have a jug of clean water, and I'm going to pour some water into the bucket. We don't need much. Maybe just about, anywhere from a cup to a cup and a half of water. So that's 8 fluid ounces to 12 fluid ounces. Then I take my trusty giant soup spoon that I stole from my mother's kitchen about 15 years ago. And I am going to almost forget to put on my respirator and turn on the air cleaner. And after getting my gloves on, I'm going to start sifting the plaster into the water. So I want you to take note that I'm using water that's coming out of a jug. I'm not using tap water. Tap water here in Florida in the summer when I'm making this mold is going to be really warm, and that will accelerate the set of the plaster. So I'm just taking my spoon and just sifting plaster into the room temperature water. You always add your plaster to water instead of the other way around. I'm just very carefully trying to sift it off the edges of the spoon and get it to land around the inside of the bucket as evenly as I can. So what we're looking for as we do this is we're looking for islands to start to form. This is called the island method of mixing plaster. So I have islands there, so we got a thumbs up, and now we let the plaster slake for about 3 minutes is the traditional time that you should let your plaster slake. The most important thing is just to make sure that all of the plaster that is risen to the top, all of the islands, get completely saturated with the moisture. So you'll be able to see the clean white peaks of those little islands start to turn a little bit of a darker color as the moisture gets sucked up by the sponge-like plaster powder. And then, after the plaster is slaked, I go ahead and I mix by hand. So I take my gloved hand and I stick it right into the wet plaster bucket, and I work that plaster through my fingers. I make sure if there's any lumps that I squish them down, and this provides a really nice, consistent, even texture to your plaster, which is really important. In a way, this first coat of plaster is the most important because this coat of plaster is the one that transmits all of the information from the surface of our clay into the surface of our casting. So we want to make sure that this coat in particular has a nice, even, fluid consistency to it. Plaster is something that is pretty flexible. You can have more water, you can have less water, to a certain degree. There's a little bit of wiggle. You might even mix this to be a little bit more wet so that that plaster really flows in and captures a little bit more detail. I'm using a 1-inch chip brush, and I wet the brush in my wash bucket before I started using it to prime it, get it ready to accept the plaster. And then I dip it in the plaster. I load it up with a bunch of plaster and I just kind of tap it onto the surface. So I'm not brushing, I'm not working the plaster into the clay. I'm using the momentum of the flowing plaster to push air out of the area around the clay and to let the plaster flow into that area. So this method gives me very few air bubbles. I'm able to get that plaster to soak up all of the detail of the clay, and I really don't trap much in the way of air by doing this. And I'm trying to work fast because this plaster only has a pot life of about 10 minutes. So I have a very short time to be able to work with this plaster. Oops, almost forgot. So I messed up here. I am putting petroleum jelly on the wooden base at the bottom of the sculpture. So this wooden armature that I use to support the sculpture needs to be coated with petroleum jelly to keep the plaster from sticking to the wood. Petroleum jelly is a very important material to have on hand, and it's what you want to coat anything with any little bit of porosity that you don't want plaster to stick to. I'll often coat my wrists with Vaseline. There are some materials that give me a little bit of an allergic reaction, and having that barrier of petroleum jelly is even helpful for your skin. It'll help keep plaster from sticking to body hair. If anyone's ever done a life cast, they know that petroleum jelly is an important part of that process. Getting back to plaster, this first coat, you have to really capture the impression of the clay, and that's why we call it an impression coat. And using a fluid plaster and really applying it with a little bit of force is a great way to make sure that you don't have any air bubbles and you get every little bit of texture. Some people even use their hands and they flick plaster. So they dip their hand in the bucket and they flick the plaster onto the surface. And that's not something that I prefer to do. I find that I can get the majority of the plaster on the clay or on the mold when I use a brush, and I can get just as good results, whereas it takes a lot longer and I waste a ton of material if I start flicking plaster. Maybe some people are more skilled at throwing plaster than I am, but this is the method that works for me, and I think everybody should do whatever works for them. One thing to consider is that this batch of plaster is probably going to be too stiff to work with in anywhere from 10 to 20 minutes, depending on the temperature of your water. So colder water makes plaster set slower, warmer water makes it set fast. And I would like to try to get through this whole section of the mold, get one nice even impression coat over the whole thing while the plaster is nice and fluid. So what I did was I started with the most detailed areas to make sure that I utilized the plaster at its most fluid state. The aluminum flanges tend to resist the plaster sticking to it when it's very fluid. You'll see that the plaster kind of rolls and drips right off the edges. But as soon as the plaster starts to thicken a little bit and it becomes more of a heavy cream consistency, a little closer to a sour cream consistency, then it'll start to stick. So you have to learn how to use the plaster as you have it. You have to learn how to control multiple batches at one time sometimes. Sometimes I'll have 3 different batches of plaster going at the same time, and I am waiting for one to get very thick, and I might mix up another one and use it really quick while it's fluid, and then hopefully by the time I'm done with that, my other batch hasn't stiffened up. That brings me to the idea of washing your brush. You want to make sure that you're washing your brush every once in a while, especially if you have multiple batches of plaster going. You're moving between batches of plaster. One batch of plaster that's already starting to set up can sort of trigger a fresher batch of plaster so that it sets up too quickly. So anytime I move between pots of plaster, I make sure that I'm cleaning my brush. I'll often clean my brush in the middle of a pot of plaster because the plaster inside the bristles is getting overworked. There's extra friction going on as the bristles move around, and that will cause the plaster in the bristles to set up faster than the plaster in the bucket. I'm now starting to mix my second batch of plaster. This is going to be for the second coat of plaster over the back section of the mold. When I start putting on the plaster, notice how there's a little bit of a difference in the appearance. That first coat of plaster had a little bit of time to sit and continue to set up while I mixed that next coat. So it's got a little bit of a velvety sort of appearance to it. It just glistens a little bit. It's not shiny, but it glistens. And if you were to touch it, it's still a little soft, but it's firm. It's something that's more like a, more like a butter. And it's at the perfect stage right now to accept another layer of plaster on top of it. It's still soft enough that that top layer is going to bond on top of it very well. If you have one layer of plaster that's hard and is already starting to dry, that second layer of plaster on top of it is not going to stick as well. So especially with the first 2 coats of plaster, I like to try to get these done one after another to make sure that I have a very good bond between those two. I don't want to risk any sort of delamination between those 2 layers. This second layer of plaster that I'm brushing on is going to be the final layer that I apply with a brush. I'm going through, and there were some spots on the flanges that I did not quite get that first layer on, so I'm going to make sure that I build up a nice thick layer. Ultimately, what I'm trying to do is I want as even of a layer of plaster over this entire thing as I can get. I'm looking for maybe about 1/8 of an inch to 1/4 of an inch of thickness. So this really doesn't have to be thick. We're looking for a nice, even eggshell over the surface of the clay. So at this point, you'll notice that I'm pulling the burlap out of the bucket of water. I'm gonna stick it into a second bucket that has a smaller third bucket on the bottom to create a little bit of a space. And I'm letting it drain for the next step, which is going to be adding some strength to this thin little shell that we have built. So we're about to add some strength and structure to this section of the mold. But first we're going to make sure that we go through and give everything a nice spray, keep everything nice and wet. So we not only want to keep our clay wet, but we want to keep our plaster nice and wet. If that plaster is nice and wet, we have a better chance that these layers of burlap and plaster are going to bond really well. If we let that plaster get a little dried out, then it's possible that we'll get some delamination. We have about 1/8 of an inch to 1/4 inch of thickness in our brushed on plaster shell. And now what we're doing is we're going to cover the entire shell with at least 2 layers of burlap. We have to strike a balance between having this mold be strong enough to remove the mold from the clay sculpture, but also engineer it in a way so that it's weak enough that we can peel it apart and remove the mold from the hard cast piece of plaster that we're going to cast inside the mold. My method for doing that is to keep the mold as thin as I can. So I have a very thin brushed up layer, just an eggshell with a very thin layer of plaster and burlap. But that's going to be very rigid, and we have a little bit of structure there to hold things together if it breaks. Where all of the strength comes from is going to be from building up these edges really thick with a lot of burlap. We're going to end up having 3 times as much burlap and plaster around all of those edges compared to the areas between all of the edges in the middle of the mold. After we have that mold established, then we just have to go back and reinforce it with some of that electrical conduit that we talked about a little bit earlier in the video. And that's where the real strength is going to come from. That's going to allow us to have a strong, rigid mold that is very likely to stay intact when we pull this mold apart from the clay, but it's also going to come apart really easily when we need to get the casting out of the inside of the mold. So I'm taking rectangles of burlap that are about 5 inches by 10 inches, or maybe 4 inches by 8 inches. I don't really care too much about the exact size. I've just found that this is a comfortable size for me to work with. It fits in my buckets. I'm going to dunk that in the plaster, fold it in half a couple times, and squeegee out the excess plaster with my fingers. Then I'm going to unfold it to the point where
it's only folded over once. So essentially we just have one doubled up piece of burlap. So 2 layers of burlap. And I take the folded edge and I stick that up along the edge of the flange that we built with aluminum. That folded edge is a little bit neater, a little bit cleaner. It doesn't have, spiky strings hanging off the end of it. So I use that folded edge along the edges of the flange. And then I let the rest of the piece come down and cover over the surface of the sculpture, making sure that that burlap bridges both the flange and the surface of the sculpture is going to give us a nice unified strong mold. After I place the saturated piece of burlap down onto the surface of the mold, what I then do is take a moment to run my fingers over every little bit of that piece of burlap. I want to make sure that I'm ironing out any air bubbles that might be stuck underneath that layer of burlap. I want to really stick everything down and smooth out the surface of that burlap. I want to make sure that that burlap is conforming to the texture underneath. I don't want to have any voids in between our brushed up layer of plaster and our layer of burlap and plaster. What's going to happen then is when I go through and I do some sanding and some work on the inside of the mold, it's likely that my tool will poke through and I'll end up losing some small section of the mold to that air pocket. Then I would have to go in and try to figure out how to repair that. So just taking an extra moment to smooth out that burlap and plaster on top of the surface every time you place a piece down really does go a long way to making sure that your mold is nice and strong and saves you time in the long run. So what I'm doing is I'm working my way around the outside edges of this piece of the mold first. I want to make sure that I build up a lot of strength along these edges. This burlap, when mixed with plaster, is a very, very strong material. It's very stiff and very rigid, and it's much stronger than a thicker piece of plaster that doesn't have any burlap in it. So what this burlap does is this burlap gives us the structure. It gives us strength in a way that plaster doesn't have on its own. Plaster is very hard, but it's also very brittle. This burlap doesn't make the plaster less brittle, but if the plaster does crack, this holds everything together. By using this plaster soaked burlap, we can make a very strong mold that is really not all that thick. This lets us make very thin, lightweight molds. What I'm doing here is I'm taking a little bit of the leftover plaster as it starts to thicken. There may be some threads of burlap left behind in the bucket also. And I'm taking that thickened plaster at the end of my batch and I'm trying to fill in some of the really deep cavities and crevices on the underside of this mold. This sculpture has a really irregular surface on the bottom where I've left the clay very unfinished and open. And by using this thickened plaster to fill in some of those deeper voids and areas underneath, that's going to make it a lot easier for me to build up the burlap layer on top of it. The burlap won't have to get pressed down to fill in such deep cavities, and I'm a lot less likely to have big air pockets and voids. So again, it's really helpful to take advantage of the plaster that you have. If you have really thin plaster, you have to find a way to use it effectively. And when you end up with a little bit of quickly thickening plaster at the end of your bucket, you have to figure out a way to take advantage of that situation and find a good use for it. You're going to give everything a spray, keep it nice and wet. At this stage, we have one doubled up layer of burlap covering everything. Now we just have to reinforce those edges. So what we're going to do is we're going to build up 4 more layers of burlap, meaning 2 more doubled over pieces onto that edge. That'll give us a layer of 6 thicknesses of burlap. So I'm going to work my way around this entire outside edge of the mold. So what that means is I'm not just working my way around where the metal flanges are, but we also have to strengthen that open edge on the bottom. So we have to try to think about making a complete circle all the way around. As I place these pieces of burlap onto the flanges, I'm making sure that these pieces of burlap are a lot wider than the flange is. So what I want to do is I want this piece of burlap to overlap both the flange and I want it to overlap down onto the sculpture. So I want to have one contiguous piece of burlap that's connecting the surface of the sculpture to the flange. That's going to make it a lot less likely that our flanges would break off when we have to try to take this mold apart and remove it from the clay underneath. So I have one doubled up layer of burlap. That's one piece of burlap that's been folded in half and dipped in plaster. And I have one layer like that along all of the flanges and over the surface of the entire sculpture. And now I just need to address this bottom edge. So we're going to treat this edge that wraps underneath the bottom side of the sculpture just like we do the areas with the flanges. Because that's one of the edges of this piece of the mold, we need that to be just as strong as those flanges are. The mold gains a lot of strength by having those flanges stick up at a 90-degree angle to the surface of the sculpture. It ends up working kind of like a piece of angle iron. If you've ever tried to bend or flex something made out of angle iron, you'll find that those two perpendicular planes working against one another are incredibly stable. And that's why angle iron is such a popular thing to build with. We're essentially making a profile just like that angle iron by building up some layers of burlap along this flange. On the underside of the sculpture, the way the mold kind of wraps around to the bottom of the sculpture gives me a change in profile. It gives me a little bit of that 90-degree angle. So if I build up the same thickness of burlap on that underside, I'll feel like it's a pretty strong section, and I won't have to worry too much about breaking that bottom edge. I'd like to reiterate that you have to strike a balance between the mold being strong enough to survive the process of being peeled away from the clay, and you have to make it weak enough that it doesn't take you forever to deconstruct the mold in order to reveal your casting underneath. Striking that balance is not the easiest thing in the world. It takes a little bit of practice, and you might give yourself a little bit more work the first few times that you do this, because you might think that your mold is strong enough to peel apart from the clay, and you might crack it and have to do some repairs. And that's a learning experience. That's okay. That's how we learn. And the great thing about plaster is that it is infinitely repairable. You can always fix any problem. So don't get panicked when something does break. But at the same time, know that it's just going to take you a little bit more time to end up with the completed finished product that you're looking for.
Now that I have the basic shell established on the back of the sculpture, I need to build a shell onto the two pieces that make up the front of the mold. So we have a little bit of plaster that leaked through in some various spots. That's totally okay. You don't need to worry about that at all. That is just going to become part of that section of mold. What we do have to worry about is if you have any, large chunks of, any large chunks of plaster that hang over from one side to the other, then you might want to put a little bit of Vaseline to, keep those things from sticking. Underneath here, I have a little bit of burlap and plaster that are wrapped around the end of this shim. So I might just dab a little bit of Vaseline onto that spot right there. And that'll keep this section from sticking to the little bit of the back section that we have showing through towards the front. Once you finally have 2 layers of plaster and burlap over the entire mold, plus your 6 layers of plaster and burlap around all of the edges of every single piece of the mold, the next thing to do is to use some plaster to try to fill in some of the gaps around those flanges. So where you have those parting lines and where you've built up the 6 layers of burlap, sometimes there are some spots where the burlap just didn't quite flatten out and didn't quite stick to the layer underneath quite as nicely as you would like. So I just take some plaster and try to force it down into any little bit of an opening that I have in those walls. We might have to, hammer against those seams with wedges. So we want to really stiffen those things up and not leave any air gaps for that plaster and burlap to collapse under the force of a wedge or something like that. All right, we did it. This is a finished shell. The one thing we have to do is add the metal reinforcements to keep these thin pieces from cracking. So what we've done is we've made a nice thin shell, and it's very thin and very strong, but plaster is brittle. So we do need to add some metal structures to the outside. Those are going to act as handles so that when we pull these pieces apart, it's going to be, a lot easier than trying to grab these little edges and, worrying about cracking them. We're going to attach some steel pipe right to the outside, and that's going to help us hold on to these things and yank them away. Very carefully yank away. I shouldn't get carried away here. So what we're going to do is what I'm going to do is it is the end of the night for me. I've been working all day, and I'm at a stopping point for the evening. So this needs to stay wet because plaster is going to bond better to itself when it's wet. So I'm going to wrap this up in a plastic bag after spraying it with a little bit more water, and I'll come back to it tomorrow. If at any point you need to stop during the mold making process, just make sure that you do that same thing. You spray it with water. Maybe you add some wet rags if things are really dried out. You want to keep everything nice and consistently wet through this entire process. If the plaster starts to dry out, everything's going to start to shrink and do different things. And when you put more plaster on the outside, say I were to leave this uncovered tonight and I were to put the metal reinforcing structure on tomorrow after letting this dry, this plaster would start losing enough moisture that when I put the fresh stuff on top, it would suck moisture away. And the new stuff would not bond very well to what's underneath. So I would go to try to pull this piece apart, and I would probably just end up pulling those metal structures right off the surface. And that's not something that we want to do. That makes it a whole lot harder to get your mold apart in one piece, and it makes it more likely to warp and change shape and distort as it goes through the drying process and you continue to handle it. So it's a whole lot easier just to try to keep this thing wet all the time. It's part of why I've been spraying it the entire time. Even as I'm working on the plaster on this side, I'm spraying the plaster on the opposite side. So we're always keeping this as wet as we can. But for now, I'm going to wrap this bad boy up and call it a night. Alright, so let's talk about what we're going to do to reinforce this mold. We've made this beautiful, nice, even, thin shell across the whole piece. We have these nice flanges that are around the outsides and around the bottom edges that are going to add strength. However, this is not enough strength to be able to easily pull this piece of shell away from the clay sculpture underneath. So what we need some sort of handle. We need some sort of structure that's going to give this thin shell a lot more rigidity. So there are different ways of doing this. One way of doing this would be to make some sort of a grid of burlap spines that are sort of run across the form in a grid pattern. That's something that I've done, but I think it takes a lot of time, and I find that when I add these metal structures, that I'm able to add enough burlap to do some of that job, but you're also adding a whole lot more structure in other ways. So rather than just making a grid that follows the surface of the form, we can connect this shoulder to the top of this head up here. And instead of this being a weak point in through here, where we have this big part that sticks out down here and this big part that sticks up out here, and we have a sort of joint in the middle, those are likely to sort of fold against one another. So we can connect this shoulder to this head, and we can make a triangle. That triangle is going to make this very, very strong. That would be a lot harder to do with burlap. You could do it, but it's a whole lot easier to just take a little scrap of steel pipe and we can make a little bridge like this. This is a nice, easy way to add a whole lot of strength. We'll use burlap to attach this. So we'll wrap this in burlap and plaster and we'll stick that on. We'll have a second one that runs from the forehead down to the hand. And then maybe we'll have one more that runs across this way. Maybe that'll just be some burlap. But whatever we do, we're trying to make sure that we're adding these bits of structure that run in some sort of a third direction away from the current structure that we have. So we have this big shape here and this big shape here, and they sort of come together and make a dip in the middle. We don't want any cracks happening through here, so If we connect this together, we're completing a triangle here. Triangles are incredibly strong because once you establish that triangle, it can't bend or move in any way without changing the length of any of these legs. So just try to build in as many triangles as you possibly can, and you should be setting yourself up for a pretty strong mold. If I come around to this side already is roughly triangular. So what we'll be doing is we'll be taking some more pieces of conduit. This is still a little bit short. These are just the scraps that I have handy from a previous mold. We're going to cut new ones, and I'll show you how to bend them to be almost as elegant as this beautiful piece. And we're going to create a triangle here with some slightly longer pieces. And then again in the back, we're going to do the same thing. I happen to have a piece from a previous mold that is a pretty good fit already. So I'm just going to modify this just a little bit, and then we'll add in a couple more pieces that connect up to the top of the head. And we're going to try to give ourselves some extra dimensional stability to keep this very big flat piece from moving and changing on us. One thing that we want to be careful as we're thinking about starting to take this apart, as we're setting ourselves up to have this piece of plaster function as a tool for us, is that plaster is likely to move as it dries. So plaster warps and changes as it dries, just like wood does. So we are liable to get some distortions if we don't handle this mold properly, and if it's not supported properly once we pull the plaster away from the clay. So if we have a good solid structure of steel tubing attached to the outside of this, that's going to be a huge help. The other thing that we're going to do is we're going to let this mold spend as little time in separate pieces while it's wet as possible. So what I do is I take it apart and I get it all cleaned up inside as quickly as I can. I pull out all the clay, and then I put the mold back together using clamps, and I leave it clamped together. I might add bolts depending how I'm feeling. I think I will be for this mold, but I bolt it or clamp it together and I let it dry in that position. And what's amazing is after it's dried, you find that the pieces actually kind of lock themselves together a little bit. They sort of stick together, and you have to apply a little bit of pressure to get them to pop apart again. If things are a little bit stuck together, you're just going to very gently start to pry things apart in a very controlled way. So I'm going to just take my hands and just give it a little push, a little squeeze, and that's all that tension that was trying to warp and twist those pieces as they dried. And it's really a relief every time I pull one of those empty molds apart after it's dried, and I see that it goes back together again perfectly. So that is the key for having proper registration and getting all of your pieces to fit back together again. We're going to make them nice and strong with lots of steel on the outside, and then we're going to be very careful drying them in a proper fashion. All right, so let's get started. Let's get our tools and materials together, and then we'll get going on reinforcing this mold to make it nice and strong. So the tools that we're using for that, this is one of my favorite tools for dealing with this conduit. If you know any electricians, you might be familiar with the tool that electricians use for bending conduit. Because they need to keep the inner diameter the same so that when they pull their wires through, you don't have these kinked tubes. Everything needs to be curved nice and even. I don't have to worry about that when I'm making a mold because I'm not running anything through the tubes. It doesn't really matter what they look like. So I actually use these rebar benders, and these little pins on the end of the rebar benders, they can lock around a piece of tubing, and I can use these as big levers, and I can make very tight turns. And these things are great to have. These are very hard to find. I think I might have bought these from somebody who was custom making them on eBay. I think it would be very easy to make one yourself, or to have a friend who has a welder make one for you. These are basically a 5/8 inch diameter pin on a 1/2 inch or 5/8 inch diameter plate. You could just have one long vertical piece here, and you could just have 2 pins. But having this plate with the triangular configuration here really is a big help. So if you can figure out how to get your hands on a set of these, it is an awesome tool if you're bending anything. I use these things all the time. So in a minute, I will give you a demo of how I use these, and we'll start making some parts and pieces to stick onto this mold. I'm going to start with the easy part. I'm going to start with this piece that I thought was already a really good fit. So I just need to trim a little bit off the end over here. Since this is already all bent up, I don't think that my rotary tubing cutter is going to be the best tool for this, because I want to cut very close to one of these pinched bend points. So I'm just going to use the good old hacksaw. And I'm going to chop that off, and then I will give this a little bend, and we'll set that aside to go into that spot. All right, so we're going to clamp this in the vise real quick, chop off that end. I'm going to bring it over to the mold and mark the place where we want the bend so we can have this fit just a little bit better. Then we're going to come down to the floor, and I find it easiest to use these benders when leveraging against the floor. I didn't quite have enough weight, I didn't quite have enough leverage to bend it with just one. So I'm going to use both of my bending bars and leverage off of one another and just put a little bit of an extra bend in there, right where that black line was. And then we bring it back. Everything looks good. Nice close fit all the way around. So we are done with that piece. For the majority of the rest of these pieces, I'm going to use brand new 1/2 inch conduit. I don't need anything too thick and heavy, so I'm going with the lighter stuff. I've marked it in a few places, and I'm using this rotary tubing cutter to score and snap off the different lengths that I need. I'm building some triangles out of the different lengths, and now I'm going to use some packing tape in order to secure them in place just long enough that I can get some plaster and burlap on there. So it's often very hard and frustrating to figure out how to hold these things in place long enough for your plaster to set. And packing tape is my most recent innovation in figuring out how to hold these things in place. It's cheap and easy, and if I can make the packing tape stick to itself and to the table underneath the sculpture, the tape holds onto things pretty well, and it's easy to peel off again in the end. The next step is to permanently adhere these pieces of conduit onto the outside of the mold. We're going to do that with some slightly longer pieces of burlap dipped in plaster the same way that we reinforced the flanges and everything earlier in the process. So I'm using maybe pieces that are 12 to 18 inches long instead of the 8 to 10 inches long previously. That gives me a little bit of room to sort of wrap these around the conduit and stretch back to the mold if there's any sort of a gap in between. I wouldn't worry too much about some sort of a gap. You can see in some of these places where I've created that triangle, the burlap has to be sort of twisted around the conduit and then make up a big gap before it reaches all the way back to the surface of the mold. So I'm just putting 1 to 2 pieces on each section of conduit at this point, just to get things tacked in place. All right, so I've let the mold sit for about 45 minutes or so to make sure that these little plaster tacks are nice and strong. Now we're ready to take off the tape and attach all of these braces a lot more permanently. Pay attention to how I am not covering every little bit of this steel tubing or this conduit with burlap and plaster. We want to leave some areas accessible. We don't need to completely encapsulate this thing. Again, this is where we have to find that balance of making something that's strong enough to be removed from the clay, but not so strong that it takes forever to take apart when we need to remove the mold from the final plaster casting. So I'm leaving some areas where I can grab onto the bare conduit. These areas will act as handles, and it's a good place to get my saw in when I go and try to remove all of this plaster and burlap and steel tubing when we have to deconstruct the mold. Having some gaps in there, having some places to get a tool in to start breaking things apart really is a big help. After all of the conduit is attached, the only thing left to do is address any little bits and bobs that might have been forgotten along the way. I have one spot along a flange where I had run out of plaster when I was trying to fill all of the gaps along the flanges. So I've got a spatula and a pot of plaster that's already starting to thicken up a little bit, and I'm just going to scoop up that plaster and dump it onto that flange so I can smooth it out with my hand and really push that plaster down into any of the crevices that are along that flange line. So once this is complete, then all we have to do is sit and wait for the plaster to be set up. Before we take the mold apart, we have one more step to clean up these flanges a little bit further. So we need this plaster to be set up before we can address that. All right, so we have finished applying plaster to this mold. Finally. Well, actually, this is a small mold, but it does feel like it's taken forever, doesn't it? So the next thing to do is we need to make sure that we clean up these seams. My plan for this mold is to soak it in a large tub of water, and that water will soak through the mold. It'll soak into the clay, and the clay is going to expand as it sucks up more water. And what that's going to do is that's going to help split these seams for us. These seams aren't going to split very well if we let them exist with this layer of plaster that's, sort of float over the top, between being a little sloppy with the burlap and then going back in and trying to fill that negative space between the layers of burlap. And we have to do something to remove this extra material and work our way back down to that metal shim that we inserted into the clay. So what I'm going to do is I'm going to show you a couple ways to remove this extra material and get down to where you can see that nice thin little metal line from the shim material. So the first way that I like to do that is by using a Surform. A Surform is made by the Stanley Tool Company, and it's basically a cheese grater. And these are marketed for use on wood and other soft materials. It is awesome on plaster like this. The only drawback is that we have a lot of burlap mixed into this plaster. So this burlap is going to clog up the teeth of this Surform. But regardless, it is often the right tool to use for the job. There are spots where it's just easier to get one of these in, there are spots where this isn't going to fit, and you need the miniature convex version of the Sureform, which is this little handle. So, like this area in here, I'm going to have to work pretty hard to try to shave away this material to reveal that metal shim underneath. So the other thing this is going to do, other than getting through to that metal line, is this is going to give you a nice squared off reference point for how this mold should fit back together. Once we take these pieces apart and we go to put them back together, it's going to be really important that we have this nice square relationship between the two sides. So we'll know that if we get a bump running across this flat surface, that the pieces are misaligned somehow. So this is important to remove as much material through here as you need to get down to that gray metal line of where our shim material was, and to square everything off. So I'm just starting to reach that aluminum layer right here. So that's exciting. It means I shouldn't be too far away up top. So this will take a little bit of time and effort to get around the entire sculpture and make sure that you're revealing that metal shim. The other thing you're going to have to do is clean your blade. This blade tends to get clogged with the burlap fibers. So as you shape away, you're cutting away little bits of burlap fiber, and those are all getting caked and clogged inside this blade. So I like to have a wire brush to brush these out. I often pop the blade off and I brush it out from both sides, and then I put it back on the holder and I continue working. Another tool that's often useful for this part of the process is a razor knife. So this retractable blade razor knife is not the ideal tool, but again, when you're getting into these tight areas, sometimes this knife does make sense for cutting through those lumpy clumps of burlap fiber and getting into the tight spots. The blade is sharp enough and the aluminum shim material that we used is soft enough that you should be able to start slicing through that aluminum shim. And then you'll know that you've gone far enough, which is fantastic. So I have some spots in here that are definitely going to be difficult. So I'm going to try to make sure that I cut away from myself and I can shave this material away in a pretty satisfactory manner. All right, I've got a little bit of aluminum showing there, so that means this is doing the job. There's one more tool that can be a tremendous help when you're trying to take care of these edges. And it's not a tool for everybody, but if you have the means, if you're comfortable with it, I highly recommend it. So that would be a reciprocating saw with a coarse wood cutting blade. So this is the blade that I'm going to use. I have my saw behind me, and I'm going to gear up and I'll show you how well this works. Okay, we're going to put a knot in the cord here so we don't pull out. That's an important detail. The next very important detail is eye protection. I'm an artist. Eyes are, the most important part of my body. I need to be able to see what I'm doing. So I do not take any chances, and I wear regular glasses, and then I always put on a face shield over the top. This is wet enough that I don't think I'm going to be making much dust, so I'm not going to bother with my respirator for this part. All right, so that does leave a bit of a fuzzy edge behind on us, but you can see how that is a much quicker way to square off the top of this flange and to reveal that parting line where that aluminum shim was. So that is a great time saver, but there are quieter, safer, less messy ways to do this job. So don't be afraid of the reciprocating saw. Don't do anything that you don't feel comfortable with. It's safety is the most important thing. You don't want to hurt yourself. You need to take all the precautions that you can to make sure that you continue making work as long as you can. Speaking of safety, another thing that we have to worry about while trying to be safe in the studio is how we're going to lift this heavy piece of clay that's now covered in plaster and now weighs a whole lot more than it did even before we started making the mold. This plaster is not very heavy when it's dry, but right now it still contains a whole lot of water weight. As you should know, we've been spraying this thing constantly over the course of the mold making process. So make sure that if you don't have the proper studio set up to safely lift this by some sort of mechanical means, and you need to do it by hand, make sure that you get some help if you're not up to lifting such a heavy thing. Especially moving sculpture. Sculpture is an irregular shape, and you might be surprised at where the center of gravity is sometimes. So I happen to have a background in rigging, and I am comfortable doing this rigging, but even here there's some mistakes that I made that I'm not super proud of, that you'll see at the beginning of the next video when we go to remove this mold from the water. So stay tuned for that. Because whatever you do in the studio, you're constantly making mistakes and constantly learning, and we just want to try to minimize those mistakes and be as safe as we can to minimize the risk of injury. We want to be making artwork rather than having to recuperate away from the studio. All right, we've done it. We have made a plaster waste mold. We are going to fill this bin with water, let it soak overnight. Hopefully the mold will start to open itself up with the pressure of the clay pushing things out from the inside. So we're gonna pick up with the next video at that stage in the process. In that second video, I'm gonna be showing you how to go from this gnarly looking piece of plaster and turn it into a finished casting like you see here. So this is the ultimate goal, is to reach a perfectly finished casting just like this, and I'll be showing you just how I get there.